Hello all, welcome to this session. I just want to inform you all this that XLR is now 360 DigitMG in USA, Malaysia, Hyderabad and other franchisee locations. The reason why we have changed the name in certain locations is because we are experimenting with the name change, right? And D and T stands for Digital Transformation Management for M and G for governance. And digital transformation is the way forward. That is the reason why we have changed the name to 360 DigitMG. All right, that's point number one. Welcome to this webinar on video analytics. We will be making use of a Python library called as OpenCV. And we will be using certain algorithms to identify moving objects within a video. Say there is a video which has bunch of cars which are going on the road. What if one of the vehicle meets with an accident, right, or gets involved in an accident? Say there was a pedestrian, there is this car which just passes over that pedestrian and then tries to run away from the accident site. Can I monitor them? Can I track them and nail them down, right? By tracking them from CCTV after CCTV, screen after screen. Can I do that? Yes. There are a lot of algorithms which are available for doing the same, right? We will discuss about a few of those. Here is the agenda. We will discuss about what is OpenCV and its applications. By the way, this webinar would last for maybe 40 minutes max, right? So we will understand about OpenCV. We will understand about object tracking algorithms. And then we are going to discuss about Gunnar Farneback's algorithm, right, which is used in dense optical flow. A lot of vehicles are going on. How do I even track the concerned vehicle which got involved in an accident? Or another application of the same is, can I count number of vehicles which are crossing a specific traffic signal? We'll discuss that. And finally, we will do a simple hands-on before we wind up. Hands-on, each time there is a new version or a small upgrade in your libraries or packages, your programming languages act weird. Hope that doesn't happen, today. OpenCV stands for Open Computer Vision. It was developed by Intel in 1999. Over years, people have improvised upon that, and it's open source basically. The current version is OpenCV 4, right? It's the most stable version as on today, right? So tomorrow, if there is any upgradation, we cannot guarantee that the previous lines of code will work well, but nevertheless, today it has to work well. A few of the applications include facial recognition system, identifying the humans, identifying who that person is. Those kind of business problems can be solved using OpenCV. Gesture recognition. Is a person dancing? Is a person walking? Is a person running? Those kind of gesture recognition, things can be solved. Object identification. Identifying whether there is an animal in the video or whether there is an object, right? Is there a car? Is there a truck? Those kind of things can be solved using OpenCV. Segmentation and recognition. If you give me a scenery of a densely populated sightseeing place, say a beach on Goa, for example, can I actually segregate all the humans? Can I give them a specific color? Can I segregate sand and give it a different color? Can I segregate sea, water, and then give it a different color? Can I do that? In the sea, if there is any shark, can I give it a different color? Would that help the people who are taking care of the beach, in helping them identify whether there is a shark approaching humans or not? Can I do that? Oh yes. Motion tracking. If I keep, say there is an object, right, or a human eye, for instance, and if I keep moving the human eye, my human eye should be tracked, basically, right? That's called as motion tracking. And then augmented reality. How many of you all attending here are aware of augmented reality? Anyone? You might want to use the chat window to respond. Is anyone aware of yeah, Bharat, Pokemon, yes, right? And many more, basically. I mean, the applications of OpenCV are a lot. A few most prominent applications have been listed down here. And when it comes to tracking your object, tracking the vehicle which is running away, etc., from this accident site, having met with an accident, there are many. Boosting tracker, MIL tracker, which is multiple instance learning. Then you have KCF, which is kernelized correlation filters. TLD, tracking learning and detection tracker. Median flow tracker. Go turn tracker, which uses CNN, convolution neural network. Then you have Mose tracker, which is minimum output sum of squared error. There are a bunch of these which are available, right? And are we going to discuss any of these or no? All right. There were 3 things or 4 things rather, which we intend to cover as part of the next webinar, which is median flow tracker, MIL, KCF, and TLD. We'll do that as part of our next webinar, as part of the series of webinars. So please stay tuned to that. Right? But today, we are going to discuss about Gunnar Farneback's algorithm. Right? Did anyone hear about this in the past? Or any doubts until now? Are you clear about the applications? Okay. Perfect. All right. So this Gunnar Farneback algorithm was developed basically to identify objects which are moving, and when there are a lot of objects moving, for example, say there is a traffic jam. When you have traffic jam, you'll have a dense set of cars which are passing, right? Which are passing on the road. How do you identify that? That's called as dense optical flow, basically. Yeah. And then we will do a small hands-on now, right? Even before we do hands-on, a few things, right? Please do not assume that I'm keeping you all as captive audience here, but let's see. So there is this Jumpstart scholarship program which we have launched. Okay, and this scholarship program offers 5 different programs for people who are working professionals, for people who are students, right? Big data for managers, that's mainly for people who are at a senior position. Machine learning on cloud is the next big thing. That's for students and working professionals, because people are expecting data scientists and AI experts and machine learning experts to build machine learning algorithms on cloud. Python and R programming, that's mostly for freshers basically, and people who do not have any programming background, freshers or working professionals who do not have programming background. AI-based conversational chatbot. How do you even build a chatbot, right? We have built one for 360 DigitMG. If I were to quickly take a minute and show you that. Let me show you. Okay, here it is. 1 second. Yep. So I can give my name here. Then email ID, I'll say. If it asks for a phone number, let me give my number. Thank you for sharing the details. I'll say Google. Then it says, hey, we have amazing 90% discounts up to on the courses. If I say yes, I want to know about that. It says these are the 5 programs. Yeah. You can also have an option to skip. Your application has been sent, scholarship program, you will go there. Do you want to know about the regular courses? You say yes. I say I'm studying, just as an example, right? So who is typing to me? Who is typing and who is responding to me? It's basically chatbot, which is doing that. We do not have any humans here, right? So this is the program basically. Right? This is the Jumpstart program. I'll just play this video quickly, and then we will do a hands-on. This is our Malaysia number, but that's fine. We also have for India a different page altogether. But that aside, this is the program. I request you all to actually make best use of that. Okay. So now, let me do a quick recap. Okay. Even before that, after this session, if you want access to these recorded videos, all you need to do is give your reviews on Facebook and LinkedIn on these specific links, and then you can claim access by dropping an email to inquiry@360digitmg.com, and then you'll get access to these specific videos, right? Okay. Now let me do a hands-on. Are you guys able to see my screen? Can you all please confirm? All right. I'm just restarting my kernel just to ensure that there are no errors. What happened? The name clear. Okay, seems like there is some issue. So let me first close this and relaunch this. Sometimes it acts very weird. Trust me on that. All right. Code which works 15 minutes before the session doesn't work during the session. That is how it is. If something gets upgraded. Anyways, we'll do that. I'm relaunching Anaconda. Then I'll go with Spider. Even before that, I want to ensure that we have the latest version of OpenCV. It's going wrong. Okay, let me just give me a bit. I want to quickly install. Oh, this is called as Murphy's law. Let me launch Spider and let me see what Spider has to do here. Hope it doesn't throw me any weird error as such. Just a minute while I try to get the code. Pertaining to dense optical flow. Okay, so even before you run dense optical flow, you need to import the important libraries. I'm going to import CV2. That's for OpenCV, and I'm importing NumPy as NP. Okay, then all this code that you're seeing here is to ensure that it's a user-defined function that I've written. This is to ensure that you have the dense flow in place and you have the arrows. If I run it and then explain, it will make sense for you all. So let me run this. Then all I'm doing is using cv2.video capture. I'm actually giving a specific video, which is traffic.mp4. And here I'm trying to read each of the frame, right? I'm going to capture that cap.read and then capture frame by frame starting from the first frame. And each frame when you capture, convert it to color. Right? All I'm saying is convert it from BGR stands for blue, green, and red. From blue, green, red to gray. Right? That is how I'm converting. And you have this previous frame. That's the image. And then here it is height comma width. If you don't want to use anything for height and width, you can put 0, 0. It's as good as using none. And then you have 0.5 and 0.5. 0.5 means 50% of the image scaling should happen. So whatever is the image size, reduce it by 50%. That is what we are saying here. So let me run each line and see what happens. Oh, okay. Did I not run this line? And this line? No, I didn't. So let me run this. Just cannot read this. So just because I'm getting these kind of errors, I wanted my friend Sharath to be here. Sharath, can I make you presenter? I think I'll make you host and then you'll be able to unmute yourself and then speak.
Yeah, Bharani.
Yeah. Can you just help us by running each line? I wish to explain each line why you run that.
Okay. Okay, let me check. So you're facing an error, is it?
Yeah, yeah.
Let's try. I just launched the same code.
Okay. Can you run from line number 5 until line number 21, 22, I think? Those things I'll explain later. Yeah, until 23, yes. Perfect. Can you now go to line numbers 26 and run that line?
Okay.
Perfect. Here you can probably um,
Once again.
yeah, sure.
Yeah.
Yeah. Can you run that line?
Line number 28. Yes.
Perfect. Can you run line number 30? Very good.
Okay, I'm facing an error. Is the same error that you also got?
I got a different error altogether.
Okay.
This is what happens, I mean, just a small updation and then previous line of code will not work, unfortunately.
Maybe I just had to update my CV2 package somewhere in the afternoon. That could be the issue.
Oh, okay.
Mm, okay, let me quickly check what is this.
Okay. You can also do one more thing. If you have any other laptop on which you have not updated, probably you can use that and run the code and see if it's
Okay,
working. If it's working, then we can run that and then show it to our participants.
give me a minute. I'll just quickly check that.
Yeah, sure. We'll just take 1 minute, folks, and then we will do it.
Yes, yes, please.
While that happens, you guys can be rest assured that these are the kind of issues that you'll be encountering in your real world as well. These are pretty common issues. Just bear with us, friends, for a quick 5 minutes, and then we will be back on game.
Yeah, the other system is working. Just give me a second so that I can connect from the other system. Hello? Hello? Ah, okay, okay.
Yeah, sure, Sharad. That's a good thing. Yeah.
Bharani,
Yeah, Sharad.
okay.
Sharad, I'm unable to hear you. Are you trying to speak?
Yeah, can you hear me now?
Yeah, now it's clear.
Yeah, it's working now. Shall I execute the entire code?
Yeah, we are not able to see the other screen, I think.
You're not able to see?
Okay. Are you sharing? I'm not sure which system you're sharing, but yeah, can you just run it?
Okay, let me just. So can you see that I've removed the variables?
Yeah, yeah. I've seen that. I've seen that. Yeah, perfect. You can run it. Yeah, we are able to see.
Okay, just let me run the entire code once, just to show you the code.
Okay.
Yeah. Hope you can see the screen.
Yep, yep. Perfect. Yeah. So this is exactly what it is. You know, those arrows that are pointing out to you that that is a direction in which the vehicles are moving. That's the first thing, right? A few things, if you look at the black car at the fag end, it is showing you wrong orientation, right? That is how it will be, right? Those are all errors. Until it comes very close, or at least slightly closer, you will find those kind of arrows. As and how it keeps coming closer, you'll see that the arrows orientation starts increasing, number of arrows, and also arrows orientation starts showing towards the direction in which the car is moving. And on the left side, if you look at that, you see the dense image that is moving, right? That's the denseness that it is showing. Even if you have a lot of vehicle moving around, that dense image will show you that these are the number of vehicles which are moving, right? So this is actually not in line with some tracking a specific car alone, but this is good enough, right? And Sharad, can you also run the code which says single shot detection?
Okay, let me check.
Yeah, please. You can pause your screen and then you can check.
Yeah, yeah, please give me a second.
Yeah. So in that you can actually highlight a specific you can highlight a specific car, and then you can start tracking that.
Okay, so let me try and execute this.
Yeah, thank you, Sharad, for unmuting me. Okay, so can you just minimize the screen? Thank you. And can you just scroll up a little further? Yeah, so do you see labels, friends, there? Labels. So if there is an airplane or a bicycle or a bird or a boat or a bottle or a bus or a car, you see that number 8 is cat, number 9 is chair, line number 790, 730 to 734. These are the various objects. If you have these objects in your video, it is going to identify those with certain probabilities, right? And we are using a pre-trained model, right? MobileNet is a model. We are using a pre-trained model, and we are trying to use that. Now, if Sharath, if you can go to the video, all it is doing is it is putting a bounding box across that object, right? And when it comes closer, probability is reaching 1. But when it is far away, if you observe, probability is 30%, 40% for that red car. If you can see the red car, probability is changing, right? And the red maroon color car at the fag end, you see the probability values keep changing. This is called as bounding box problem, right? Identifying objects within a video. This is exactly what we do. So yeah, more things you can learn as part of AI training. We in AI training explain line by line, and we also ensure that such errors do not occur. Time to time, we keep upgrading our algorithms, right? Today is a Murphy's law that certain things. Okay, look at that. A guy on bike is coming, and it is giving a probability for that guy also. It's not just a car, right? Bike, motorbike also it identifies. And that's how it is, right? This is exactly what we wanted to display to you guys. All right, so let me take the presenter access. Sharath, can you please give me presenter access? You can make me a co-host otherwise. Yeah, so that is what we wanted to show, friends. I understand that today we had certain errors, but we will repeat this exercise again because our intention was to show you certain algorithms, right? So we are going to repeat this particular webinar, and I'm going to personally ensure that no code errors occur, and we are going to run you guys through median flow tracker, MIL tracker, KCF tracker, and TLD tracker. These 4 trackers is what you're going to learn, and then you can track down a single car also as part of this tracking. Okay, so that is all we had for the session. So stay tuned, stay active on our social media forums. We will be posting about the next algorithm, next webinar. And in that next webinar, we are going to explain about all of these 4 trackers for sure. And that will happen very soon. Anything from your side? If there is nothing, then thank you so much. Good night for now, and we will connect back again to run through this algorithm, or rather algorithms. All right, guys. Good night. Have a great day. Bye. Thank you.